everybody. In this video, we're going to talk about how we can represent quantitative data in a visual way. So take 3 deep breaths and let's make this math easy. All right, so when we're representing quantitative data, remember that quantitative data is data that is numerical. So like the height of an average 6th grader or the temperature in California or things that can be represented by numbers. And when we're representing quantitative data in a visual way, there are 2 different ways that we do this. So one of the ways is a histogram, and then the next one is a frequency polygon. And these 2 are actually basically the same thing. They're just drawn slightly different. So I had actually never heard of frequency polygons before I taught this class because they're basically the same thing as a histogram. So let's talk about what a histogram is. So a histogram is kind of actually like a bar chart, except instead of having categories along the x-axis, you're going to have numbers because you're representing quantitative data which are given in numbers. And so, for example, let's say that you had a quantitative data set that represented the scores that a bunch of students got on a 20-point quiz. So if we look at all of these scores, it's a big, long, messy list, and we can organize these scores and visualize them with a histogram. So basically what you do is you say, okay, well, I'm going to draw a number line on the x-axis, and on this number line, I'm going to split it up into sections. So in this case, it was split up into sections that are 1 unit wide. And then you're going to count how many data points fit within that category. So if we look at the scores, and let's say we want to see how many people scored an 18 on this quiz. Well, there's 1, 2, 3, 4, 5, 6, 7, and 8 people who scored an 18. And so this bar right here goes up to 8 because that's the number of people who scored between 18 and 19 on their quiz. So the lower bound of the section of the bar is included. So like everybody who got an 18 is included in this, but the people who got a 19 are going to be in the next one. So this little section right here is basically like everything from 18 to 18.9999999. But once you hit 19, then you include it in the next bar. And your sections don't necessarily have to count by ones. So for example, on this histogram, we have sections of the number line that are skip counting by 15s. So each one of these marks on the number line is 15 units apart. So you can count by ones, you can count by 5s or 10s or whatever number you think would be reasonable for the data set. But whatever number you count by, you need to be consistent with it. And so in this case, we can see that there are 6 data points that are between 225 and 239.9999999. And so the height of this bar communicates how many data points are within that range. And on your assignment, you'll be asked to create some histograms as well as to interpret some histograms. So for example, if you were asked how many of these data points are between 210 pounds and 270 pounds, you could say, well, here's my 210 mark, and it looks like I have 7 data points that are in this block, and then I have 6 data points that are in this block, and 2 that are in this block, and 3 in this one. So the number of data points that are between 210 and 270 would be 7 data points plus 6 plus 2 plus 3, which is a total of 18. And so you could say that there are 18 data points within this range. And you can also have comparative histograms. So a comparative histogram is where you have 2 different data sets that are displayed on the same histogram. So this histogram comes from a situation where they asked people to move a computer mouse to a target on the screen as fast as possible. So they had like a computer screen set up, and there would be like a target that would show up somewhere on the screen, and the goal was to move the computer mouse there as quickly as possible. And they did two different versions of this. So they had one where the target was small on the screen, and they had another one where it was large. And so the light purple bars are representing the time that it took to get to the small target, and the dark purple bars are representing the amount of time that it took to get to the large target. And if we look at this, this makes sense because it's obviously a little bit harder to move a computer mouse to a smaller target compared to a larger target. And so it makes sense that these light purple bars are a little bit more spread out, and that there's more light purple bars as the reaction time increases. Versus with the dark purple bars, it makes sense that they would be a little bit closer together and that people would be faster at reacting if the target is bigger. So this is a comparative histogram, and we could represent this exact same information with a frequency polygon, because basically what a frequency polygon does is it creates kind of like a line chart from the tops of each of the bars. So this would be an example of a frequency polygon that represents the exact same data that we saw on the last slide. So you can see, instead of having a bar that goes up to this point, they just put a single point there. And same thing here, instead of having a bar that goes all the way up to there, they just put a point there. And then they connect them all kind of like a dot to dot. So that's what a frequency polygon is. So to practice this, I want you guys to create a histogram for this data set. And you can choose how big your categories are, and you just want to choose something that seems reasonable for the data set that you're looking at. So pause this video, make your own histogram for this data, and then restart it to see how I would do it. Okay, so my first step here is to decide how big I want my bins to be. That's the technical name for the categories in a histogram. And so I can see that my smallest data point is $140, and my largest data point is $460. And so I think that a reasonable thing to skip count by would maybe be 20s. So to draw my histogram, I'm going to start at 140 because that's my lowest value. And then along my number line, I'm going to space these by 20s. So if I add 20 to 140, I get 160, then 180, and 200, and 220, and 240, 260, 280, 300, 320, 340, 360, 380, 400, 420, 440, 460, 480, 500, and so on. But I don't need to go any further because 460 is my largest data point. And then on the y-axis, I'm going to make marks for the frequency of how often numbers are within this range. So I'm just going to mark them like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or something like that. So then to make my histogram, I would say, okay, well, how many data points are between 140 and 159.99999? Well, there's just one data point. That's this one right here. So I'll make a bar that's 1 tall. Then I say, okay, well, how many data points are between 160 and 179.99999? Well, there's 3. So I'm going to draw a bar that goes up to the 3 mark. And that's that part of the histogram. Then I'll say, how many are between 180 and 200? Well, just 1. So that will just be 1 high. And then there's nothing between 200 and 220. And then from 220 to 240, there are 2 data points. So I'm going to make a bar that is 2 units high on that section. And then from 240 to 260, there's also 2. So I would draw it like that. And from 260 to 280, there's just 1. And from 280 to 300, it looks like we have 1, 2, 3, 4, 5. And so I would go up 5 units, which is going to be about right here. So that's that part of the histogram. Then from 300 to 320, I have 1, 2, 3, 4, 5, 6, 7. So I'll go up 2 more units to draw that part of my histogram. And then from 320 to 340, I have 1, 2, 3. So I'll just go up 3 units, which is about right there. And then from 340 to 360, I have 1, 2, 3, 4. So I'll draw my bar chart up to there. And then from 360 to 380, I have 2. So I'll draw a bar that's 2 tall. And then from 380 to 400, I have 2 data points. So I'll draw a bar for 2 there as well. And then from 400 to 420, there's nothing. But from 420 to 440, there's 1. Then from 440 to 460, there's nothing. But from 460 to 480, there's 2. And so this is what my histogram would look like. And some of you guys may have decided to count by 50s instead of by 20s, in which case your histogram is going to look a little bit different because you're grouping different data points together. But this is the basic idea of how you can create a histogram to represent quantitative data. And if you wanted to convert this into a frequency polygon, you would basically just connect the tops of the bars together. And you would do this kind of in like a continuous line. So for this one, it would look like you'd start at 0, go up to here, then go to here, here, down to 0, straight across, down, up here, and it would just kind of look like this. So a frequency polygon is basically the same thing as a histogram. It's just that you're representing it with points that are connected with lines versus drawing bars. So I hope this video was helpful, and if you have any questions, let me know.